In our last class, we completed task 1 of our compiler design, which is opening a C++ file and copying its content. In this class, we'll scan the content of our file, searching for what we call tokens. So we start by creating two files, scanner.h and scanner.c++. I mistakenly created scanner.c, but I'll later change it to scanner.c++ in a later video. So create a scanner.c++ file now. So we include the scanner.h header file in our file opener.c++ file. So this include we enable our file opener to call the scanner function on line 30 of file opener.c++. That is where our scanner was called, and the argument there is the content of our C++ file. So next we declare the scanner function in our scanner.h header file and initialize it in scanner.c++. The scanner function will scan through our file content, searching for tokens. So we need to create our tokens before we start. So we'll create a new header file called tokens.h, which will contain our tokens. Next, we declare an enum called token type, which will contain list of all our tokens. So what are tokens? I'll define tokens as a sequence of characters that can be treated as a unit in the grammar of a programming language. So they include keywords, constants, string, identifier, numbers, operators, and punctuation symbols. These are the units of our programming language. So we need to break down our script into tokens, and then we'll start merging them into meaningful sentences. So example, consider the sentence int a is equal to 500, semicolon. So the smallest units here will include int a equal sign 500 and semicolon. So these are the tokens in this file. Next, here is a sample script and list of tokens we can find here. I've compared lists of different tokens within the scripts. So the list is not exhaustive. We still add more tokens from the parser. So you can see token var, which is used to represent ints or integers. Then I have token fun, which represents function names. Then token semicolon. Token identifier is used for representing any identifier. Then token bool, token string, token comma, token string var, token bang, token less than or equal to, logical and, token star is used for star and assignment. Then slash and assignment, they are together. The star equal to is a single token. Then the same with slash equal is a single token called slash assignment. Subtract equal is a single token called sub assignment, token sub assignment. The same with plus equal to, which represents add assignment. Then, okay, at the end is supposed to be token hyphen, not token comma at the beginning here. Then token while, token left brace, token greater than, token assignment or, token shift right. Token ternary. Ternary for ternary operator. Token add self. Then you can see token void. Token pin, I won't be using it for this tutorial. It's actually a customized token. I won't be including it. You'll see token cout for printing in C++. So as the compiler designer, you are also the syntax developer. So it's your sole responsibility to determine what tokens to use for your language and what tokens not to include, how each token is used and arranged to form the language sentence depends solely on your decision. We will still include intermediate tokens like token end and token start, and some tokens will be lost along the way, like token true and token false will be converted to token number and assigned the values of 1 and 0 respectively. Then the end of every C++ file is terminated with /0, and this is regarded as token end of file. That is, the end of every string or char file will be terminated with /0. And this will be used to signal the end of our scanning process. So when we are scanning the tokens, once we scan token /0 token end of file, that means we terminate our scanning process. So next, we populate the token types enum with a list of all these tokens. Some of them, like I said earlier, will be generated later. In C and C++, the enum data are also numbers arranged in order of precedence. So example here, token equal on line 2 is equivalent to 0. Token logical OR is equivalent to 1. Token logical AND is equivalent to 2. Token equal is equivalent to 3. Token greater than is equivalent to 4, and so on, until token end of file on line 34, which has the highest value. Therefore, the arrangement determines the numerical value and order of precedence, and is very important, most especially for group recognition. Example, let's say you want to refer to logical operators. Instead of listing all of them, you can refer to all tokens less than token colon and tokens greater than token equal. Arithmetic operators is equal to tokens greater than token colon and less than token bank. Arithmetic and logical operators combined together is equal to tokens less than token bank and tokens greater than or equal to token equal. Unary operators is equal to tokens greater than or equal to token bank and less than or equal to token add self. So these arrangements are very important because we would use it to refer to operators in group. In our code, there will be times we will want to refer to logical operators. So we are not going to list all of them one after the other. So we can say tokens less than token colon and tokens greater than token equal. So it's up to the compiler designer to determine the best method for code compilation. It's not compulsory to arrange them in order of precedence. So you as a compiler designer will determine what is the best method for your design. So in this lesson, we've learned what tokens are. In our next tutorial, we'll see how the scanner scans our code, searching for these tokens, and how it's able to find tokens.